Thanks for tuning in today. Virtual Classroom Seminar, Episode 3 about ADB migrations. And today, we are going to take care on the migration part. But before we really start, let me give you a big hug and a big praise, because Oracle DBAs run the world. It's not just a slogan, it's much more than that, because nothing would work without you. And when you ever happen to come by to one of our physical events, maybe one of the user group events, I will be in India shortly. We have Oracle Cloud World coming up in October. Come by, grab a sticker, put it on your laptop lid, and show everybody that nothing in the world would turn without Oracle DBAs. So thanks for tuning in today. You are the best, and keep up this awesome work. Now, who are we? I'm Mike Dietrich. I run the product management for database upgrades, migrations, and patching in Oracle. And I have an absolutely awesome team with me. So we have Daniel today, Daniel Overby Hansen from Copenhagen. Then we have Rodrigo Jorge from Brazil in Rio de Janeiro. We have Alex Zabala, the man with the most certifications in the world, also from Brazil, but living in Dallas, Texas. And we have a guest today from our team, Klaus Gronau, who was the technical lead in Oracle ACS support for a long period for migrations. And Klaus will also show you some new development today. And what's not on the slide, we have 3 guest speakers today. So we'll introduce them later on, but it's not just us 5, we have 3 additional speakers, and we'll make this seminar as entertaining as possible. So let's get it started with our blocks. If you need more information, if you look for out-of-grade config files, for patching advice, for behavior changes, whatever, you'll find it on our blogs. MikeDietrich.de.com, dohdatabase.com, Daniel's blog, Rodrigo's blog, dbarj.com.br, and Alex's blog, alexzabala.com. And in case you need us for something special, there's our email addresses on the slide as well. Feel free to drop us an email. It's the most preferred way, actually, because if one of us is traveling, you'll receive an auto reply if we are not reading your email right away. Slides are already on Daniel's blog, dohdatabase.com, and on my blog, mikedietrich.com/slides. You can download them right away. And if you think you need more, or you missed the first 2 parts of this seminar series, it's all on mikedietrich.de.com/videos, and of course also on our YouTube channel. At the end of the seminar, we show you also the link, or you just search for Upgrade Now on YouTube, and for the put in Oracle and Upgrade Now, and then you find us. Quickly subscribe to our YouTube channel, please. So we have more than 40 hours of virtual classroom seminars, deep tech, and we will keep on doing them. No worries. Now I said, hey, this is the 3rd episode of this series. Altogether, we planned 4 episodes. So we started off with planning, then we went for preparation the last time a few weeks ago, and now today we cover the migration. And we'll finish for now this series in a few weeks with the operating part, which means how Autonomous Database will change a DBA's life. So this will be what we are going to talk today. And I would like to hand over to Rodrigo at first. And Rodrigo will kick it off now with a recap of what happened in the previous session.
Thank you, Mike. So today is part 3 of this virtual class series of moving to ADB. Before we start, let's just do a quick recap of what we learned in part 2. So first, in part 2, we made it clear that a move to ADB is always a logical migration. You cannot move things in the data file layer like you do when you do, for example, a PDB unplug and plug, or a rman backup and restore command. With ADB, you need to do logical migration, so you need to move data from the source environment to your target environment. And this makes things a bit complex because you need to check the compatibility between your source data with your target environment to see if it's gonna fit there. To make things simpler, we showed in part 2 that we have this 1, 2, 3 approach, where first we run State Explorer to get the low-hanging fruit, so to map the potential targets to go to ADB. Then we run CPAT, do a deeply analysis on your source environment, and fix all the potential issues before we do this logical migration to ADB. And finally, with CMA, we can identify the best migration method options for moving this database. So in part 2, we put a lot of focus on CPAT, showing how CPAT report works. And here, for example, it's a CPAT report that shows that if you want to go with Golden Gate to move to ADB, you need first to enable supplemental logging in your source environment. Here is an example of some of the slides we had in part 2, where for each of the checks that we showed there, we showed if the check applies for serverless or dedicated, and also where you need to perform the fits for this check, if it's whether in your source environment or in the target ADB. So here are just 2 check examples that we showed on part 2. So to evaluate an Oracle database for compatibility with autonomous database, the tool you should be using is CPAT. You can always download the latest version of CPAT from this Moz note. We recommend you to do that because we keep updating the CPAT tool in a quarterly basis, so always go to this Moz note and download the latest release from there. Now let's check with Alex how we can fix some of the issues we identify with CPAT. With you, Alex.
Thanks, Rodrigo. That was a great recap. So now let's talk about how to fix the CPAT findings on our sample database. For the simple database, when you choose the migration method data pump, as you can see, we have a few things to check. For example, on the source database, I have the 1 review suggested. On the target database, I have 1 review required and 2 reviews suggested. And for additional tasks, I have 3 reviews suggested. Even it says suggested, I recommend you to really check what you need to do on these findings. For example, on our simple database, we have the scheduler jobs that we need to check. We don't have any scheduler running on this database, but since we are using data pump method, it's a good thing to disable the scheduler jobs to not change data while you are exporting data. In case you are using an online migration with Golden Gate, in this case you don't need to worry about because Golden Gate will be able to sync this data during the migration. For directory objects on this simple database, we don't have any directory objects other than the standard. But in case you have on your database, it's a good thing to check on the target database after the migration and fix the path. For the trusted server, we don't have any database connecting to the simple database through database link. But in case you have, you may take a look on the OCI firewall. It's a good way where you can restrict the servers connecting to your database. When I use the migration method set to all, then we have more things to check. For example, now we have action required and review required. So for example, in this case, we need to fix everything. We already see a few slides ago. And now we also need to fix the supplemental logging and the streams pool size. This is Golden Gate related. So let's see one example on how to do this. So now I'm connected to my source database, to the container database, and I'm changing a few parameters. For example, I'm enabling Golden Gate. I'm adding the force logging. I'm changing the streams pool size, and I'm also adding the supplemental log data. So now let's run the CPAT again. Let's move the result to my server. And when we analyze the new CPAT result, as you can see, we don't have any action to do on our source database anymore. For the complex database, using the migration method data pump, as you can see, we have way more things to check, especially on the target database. So we need to check all the previous findings plus all this. I will not go through everything because we already covered all these findings on our previous webinar. So if you are interested, you can go to our previous webinar and watch, and you'll see a lot of examples and step-by-step on how you can fix. Also, we have a lot of hidden slides on this presentation. When you download this presentation, you will be able to see these hidden slides with all these checks and all the steps you need to do to fix everything. Now, Mike, would you mind to explain us about the connection options we have on the Autonomous database?
Hey, thanks, Alex. This was really good. Now we know what we have to fix on our source, on our target for the migration, and we are ready to go. Almost. How do we connect best? Let me discuss that. When you work with Autonomous Database, you have realized already you can download a wallet and there are predefined service names. So for Autonomous Data Warehouse, there are 3 of them, low, medium, high. And for ATP and for Autonomous JSON, which is basically an ATP with a little bit extra. In addition, we have also TP and TP Urgent. So there's now 5 choices. And which one is the best? Which one should you take? We have a clear opinion on that, and this is based on the experience in migrations we worked with, and there's clearly TP Urgent. So TP Urgent has the best capabilities in terms of how it leverages CPU resources, parallel abilities, all that works far best with TP Urgent. Now, when you browse through documentation, you may find here and there different recommendations, but trust us, we've tried it out. That works clearly best. Don't use medium. There's some research done when you go to a coffee store and you order a small, medium, or tall-sized latte. Most people go for medium, which sounds great, and it's in most of people's nature to do that, but it's not the right service to use. So TP Urgent really works best for ADW. If needed, you can request TP Urgent as well. That was very short. Let me hand over to Rodrigo. Rodrigo can discuss the storage topic.
Thank you, Mike. Now let's talk about the storage options we have when we go with data pump in a file-based approach. What is file-based approach is when we use dump files with data pump instead of DB link connecting from the target to the source environment. So when we go with the file-based approach, there are 2 options of storage where we can place our dump files, either in an NFS or in an object storage. And which one is the best? So the answer, as always, is it depends. But usually NFS or FSS, as we call in OCI, for File System Service, it's usually the best option. And why? First, because those FSS services are very easy to set up. You just click, you have a mount point, and then you can expose this mount point to your source database and also to ADB. And then you just place the dump file there, and it's going to be visible for your ADB instance to load using data pump. The performance is to be better with NFS, and also because you can configure it and set what are the performance metrics you want when you deploy an FSS. The only requirement is that this NFS, for security reasons, must be accessible in your private endpoint, meaning it must be visible in the private endpoint where your ADB sits. Now, talking back to the object storage, and one of the advantages of using that is that when you place a data pump file in the object storage and just create a pre-authenticated request, this can be easily readable by data pump. You just put the path on dump file parameter of data pump import, and then you are all set. So that's again why both have its advantage, and it depends on your use case. We also have what we call HPMT. Those are the high performance mount targets. Those are very high performance NFS systems that you can achieve up to 80 gigabits per second in read. This is a huge bandwidth. To configure that, we have those 2 links here on the slides that is available for you after this session. You can click and see some of the white papers where we compare the performance using this kind of high performance disk. If you want to achieve maximum performance but don't want to stay with those high performance disks, One thing you can do is just allocate it temporarily during your migration. The minimum subscription time is 30 days, so maybe this will fit very well for your move to ADB journey. Now back to you, Alex. Let's talk about latency issues.
Thanks, Rodrigo. So let's talk about latency. Usually, there is not an issue, but we have some great tools to help you measure. For example, ADB ping, it's a tool to diagnose any high latency issue. This tool can validate if the ADB service is healthy and not the root cause of the latency. How you can use it? You can go to this MyOracle support node, download the tool, move to OCI to your client machine and execute the tool. You can see the time to execute the SQL, not including the connection time, and you also have the connection plus the SQL execution time. To execute the SQL, you have two options, using the SQL Plus and using Java class. Another tool is the OCI ping. This tool is something similar to the command line ping that everyone is aware. You can go to GitHub, download the tool and move it to your client machine. And you have two options. The OCI ping, you can diagnose latency or packet loss issues. And you also have the comping, where you can also see the time to establish the connection to the database. To reduce the latency, the Oracle documentation is very helpful and full of advices. For example, place your clients in the same availability domain as the autonomous database you are connecting. If you are using autonomous database instance on a public endpoint, it's good to move and make sure your client are using the service gateway to connect to this database. It's also good to enable MTLS and TLS to connect to your autonomous database. And another good thing, it depends on the characteristics of your application. The TFO connection can improve the application performance by decreasing the network latency for client connections. Back to you, Mike.
Very cool. We have connectivity, storage, latency. What's missing? Maintenance windows. This is something you really need to keep an eye on when you want to migrate. When we look at autonomous serverless, and this is especially important for autonomous serverless migrations, then you have two maintenance plans available. So when you provision your ADB environment, you will see them right away and also on the dashboard. So my ADB pod here is on regular patch level. You can also use the early one, whatever you choose. It means basically that you have a predefined maintenance window. And that actually gets assigned to your ADB environment during the provisioning process. So it depends on when you provisioned it, and it depends also on the region you provisioned in. So keep an eye on that, give it a try first to see how you can alter it or what it means. But you see here in my case, I provisioned mine and it has a maintenance window now every Saturday at 7 p.m. Central European Time until 9 p.m. Central European Time. It may look very different for your environment, so please have it checked before and also try to alter that, but you can't change this afterwards, at least not as far as I'm aware. So you need to pay close attention, because when you migrate now into that maintenance window, that for sure may cause trouble. Be aware of that. So how do you monitor it? You can connect to your autonomous database environment, and you have the DB_notifications. And there you find the actual start date, the end date, if you had maintenance already, or you can also query the upcoming maintenance time frame. So here you see mine really started 2 seconds after 7 p.m. on May 24th, and it ended 2 hours and 20 seconds later. That is something you really need to be aware of, because when I migrate now my database right at this maintenance window, that may lead, it doesn't have to, but it may lead to an interruption at some point. So be really careful. Now you can postpone that. The first question you will have is, can I change this? Yes, you can, but only plus minus 2 hours, and you need to open a service request at least a few days before. So I wouldn't open the service request on the morning of your migration, do it 2 or 3 days before to make sure it gets shifted. The actual time of the day you will see most likely on the morning of the migration window. So in my case, for the Saturday maintenance window, I will see in my ADB environment, I can usually see the exact timing and how long it will be, like proposed, scheduled in the morning of the day of the maintenance. So when you plan to migrate that night, make sure you check this before. What I would do now in my specific case, I would start my migration not before 9 p.m. on Saturday. And I would open an SR and say, can we move it from 7 to 5? So it ends at 7. Then I would double check before I start, and then I would start migrating into. As I said, this is strictly autonomous serverless. When you have autonomous dedicated, you can define that by yourself. You can also have your own plan. You can define if you skip one. There are multiple options, but not in serverless. So be aware of that when you migrate into. And I hand over now to Daniel, and we start with Data Pump. Now we really start dealing with the migrations. It's time for the migration. So Daniel, please show people what to take care on.
Thanks, Mike. It is really good to know about those maintenance windows so we can find the perfect time to start our migration. And when we do the migration, of course, we use our favorite tool, Data Pump. So let me start with a few general recommendations about Data Pump. If you've heard me talk about Data Pump before, you will know that I always preach about the Data Pump bundle patch. You should never do anything with Data Pump without having the bundle patch. And this is true in this case as well. On the source database, please ensure that you have the bundle patch so we can use some of those important performance enhancements. On the ADB side, things are a little different because we apply patches in a different way in Autonomous Database. We have a lot of the Data Pump fixes in there already, but there might be 1 or 2 fixes that you need to request on your ADB instance, and you do that via a service request. One of the things about cloud migrations that I really love is the elasticity. So before a migration, we can scale up on resources to make the import happen faster. Just add as many CPUs as you can afford. Potentially, it can make the import happen a lot faster. And then afterwards, depending on your workload and your wallet, well, you can then scale down to a more reasonable setting afterwards. On the source database, you want to use parallel when you perform the export. And here our general recommendation is that you use twice the amount of physical cores in your system. That is normally a very good setting for Data Pump. On the ADB instance, we have the eCPU metric, and the parallel setting in Data Pump should generally be 1/4 of the amount of eCPUs. Depending on your data, you might be able to tweak it a little, but normally this is a really good starting point. And because ADB runs on a RAG database, we want to be able to use all the instances in our cluster. So be sure to set the right parameter so Data Pump can scale out and use workers on all nodes in our cluster. I'll now hand you over to Rodrigo for some more Data Pump stuff.
Thank you, Daniel, for those tips and tricks. It's impressive as most people, they forget to optimize that CPU setting before doing a Data Pump operation, or even apply the bundle patch on the source and target environment to optimize the full process. So those are good tips and tricks. Now let's talk about the simple method for moving a database to ADB. And the answer is Data Pump. It's the simplest approach for moving your database. And we can go with 2 ways here. One is using the file-based approach that I already talked when I showed that we can put on both object storage or the FSS, the file system service. But we also have it with DB links, where we create a DB link from the target environment to the source environment. So what's the characteristics of each of those approaches? When we go with Data Pump with files, we have more control over the parallelism. We can have multiple files, so it's very easy for Data Pump to create multiple worker processes and each of them access a different file or handle a different table. However, we have here a storage overhead. So let's say we are exporting a 1 terabyte database. We need first to put that 1 terabyte database in a dump file, place it somewhere, and then make this file visible to our Tart ADB. The good advantage is that there is no source-Tart connection interoperability requirement. Meaning, for example, if your source is 10.2, you can still use this method to move it to ADB. The only thing again is that it requires an object storage or a file storage setup in order to move this file to your Tart database. Why with data pump with deep link? What the problem is here in this method is the network throughput and latency dependency. So if your database don't sit together when using this method, you have problems especially with the latency. It's very good for small databases. However, for this method, of course, we are using DB link, so it requires a DB link setup. As we saw in part 2, creating a DB link in a serverless environment is not that simple. So if you're running an old database in your source, it's better to go with the file-based approach of data pump. And there is more about the DB link method of data pump. It's important to have in mind that data pump with network link has some limitations, especially regarding the column types and also about the performance. For example, if you have lobs, for each lob you have for each row, it needs to do a full round trip between the source and target environment. So if you have thousands of rows, you will require thousands of round trips. Now imagine if each round trip takes 1 second, it will be thousands of seconds. And if you have millions of rows, this will translate in millions of seconds, which make it unfeasible. So unless you are working on the millisecond layer here for the round trip, you should not be moving lobs using DB links. Here we have 2 URLs showing how you can measure this DB link. It's very similar with what Alex already showed on the previous slides. Imagine, for example, like we have in this slide, that your round trip takes about a mean of 1 second. So if you have some lobs in this database, this will already kill this method for moving using DB link. Also, another problem of using DB link is when you want to do the metadata import. The metadata import with DB links does not have parallelism like it does with files. So if you're handling a complex schema with a lot of metadata, then again we recommend you to go with the file-based approach. However, you can still go with DB links. But what we recommend you to do in this case is first, before your migration window, just do the metadata part. And then of course you need to ensure that your model will not change until it reaches the migration window, and then on the migration window you only handle the data part using data pump. Now let's do a demo. In this demo we will see a 19-seat database running on IaaS, Infrastructure as a Service, and this database is based on the sample schema. It's very similar to the simple PDB that Alex already showed us, just with some additional objects. We will first move this database to an ADB dedicated using object storage and also show you using DB link. So let's do the demo. Okay, let's start exporting from my source. So here what I do is I connect on my source database with my IT admin user. And here we see I'm exporting those 5 schemas. And I'm also enabling metrics and load time, so we see the data pump execution with more details. I will speed up here the things a bit so we don't need to wait much, but we see that all objects related to those 5 schemas are being exported, like procedures, functions, index, and all the tables and partitions. It completed after about 1 minute 30 seconds without any errors. What I will do now is upload the dump file to my object storage, because I will later read from that object storage to import in my ADBD. Okay, let's start the InPDP using the file-based approach. So here I'm connecting on my ADBD. First thing I will do is create my IT admin user because I will use this user to import later. I will grant PDB DBA to this user and also some quota here so it can create the master table and runs data pump. I will create also the table space to match the one I have in the source environment and allow the row ID column type so I don't have any issues while I import row ID types. And I'm also creating this directory because this is used by one of the external tables I have in the source environment. Now I will create this par file. As you can see here in this par file, I'm specifying the schemas that I exported from the source. And also in the dump file parameter, I have the full path of my object storage URL that I just uploaded. Now I call inpdp, providing this parameter file. And I will speed up things here again, so we don't need to keep waiting, but we see that all the tables and related objects are being imported, and the method used by DataPump to import those tables is the external table method, so it's reading from the object storage directly to our database. We can see all the dependencies also being imported, and after about 30 minutes and 30 seconds, it completed. Now let's try the same process using the dblink datapump method. So I will clean all those 5 schemas and call it again. But before I will create my database link, and we see the database link was created, and I will test it. So for ADBD, we can use the create database link syntax. I will create another parameter file, but now using the network link instead of the dump file. And I will call impdp providing this parameter file. So we can see it's also working pretty well. I will speed up all the objects here for those 5 schemas are being imported and also their tables and partitions. But the method here is using network link instead of external table. Now all the dependencies like constraints, index, materialized views and so forth, and it also completes successfully after 1 minute and 30 seconds, about half of the time of the other method. So I think you could see how simple it was using both methods to move this database to ADBD. Now let's do it again, but instead of ADBD, the dedicated one, let's do the same process using both file-based approach and the dblink approach, but now to ADB serverless. Let's start the demo. Okay, let's start here connecting on my ADBS. I won't export the same file again, I use the same dump file that I imported on ADBD. So first what I do, I connect here on my ADBS as admin, and I will create this IT admin user, and also again grant PDB DBA to this account and quota, so this user can create and run DataPump, can create the master table for DataPump. Here notice I'm not creating a new table space because ADBS will automatically handle the table space name conversion for me. And also I don't need to allow row ID type column because as we can see here in the official documentation, this parameter only applies for autonomous database dedicated. In serverless, it's already enabled. So again, I create a parameter file. I specify here my object storage URL, and I call impdp using this par file. I will speed up here the things a bit, so we don't need to keep waiting. And again, it's using the external table method for getting the data from this object storage file. I see all the tables and partitions. And also some dependency objects like index, constraints, materialized views, and so forth. So the import completed in 2 minutes and 50 seconds. Now let's do it again using the database link approach instead of the dump file. So I will connect again in my ADBS, and I will clean all the schemas. But here in ADBS, if I try to create the database link using this syntax, it's gonna fail because this is not supported in the serverless autonomous database. What I need to do is first create the credential for my IT admin user and later use this DBMS Cloud admin create database link syntax. So I call this package and I provide my database link name details here. I test it and it's working. Okay, now I will create the parameter file for dblink approach. And again, I'm just changing dump file for network link. And I call impdp providing this parameter file. And we can see it started and it's running without any errors. So it created all the 5 users and now is importing all the tables and partition, but here using the network link method instead of the external tables. So now it's doing all the dependencies. And it finished after 1 minute and 51 seconds, so it was much faster than the file-based approach. Now let's try to check and compare if my source environment and my target environment are reflecting and are matching on the objects. So in the left, I'm connecting my source, and here on the right, I'm connecting in my ADBS. And I will run the same command on both databases at the same time. So first, let's take a look on the table spaces that I have in both environments for those 5 schemas. So when I run this circle, I can see that Datapump and ADBS did the conversion automatically for me to the data table space on ADBS. Now let's take a look on the row ID columns if they were imported successfully. And I can see we have a match, we have 6 columns of this row ID type in both source and target environments. Now taking a look on my external tables, here I see the first problem. I have an external table in my source that I don't have on the target, but I have the tables created in both environments. The difference is that in the target environment, this table is a heap table, not an external table. Let's take a further look at this problem. I will connect back in my source environment as IT admin user, and I will do a count star on this external table. I can see it has about 900,000 rows. When I get the DDL, I have my external table DDL here created. What I will do is I will upload the file used by this external table to my object storage. And now I will connect in my ADBS, in my target environment, to check what happened to the table that was created there. First, I will create the data file directory and the log file directory in my target environment because both directories are used by the external table, as you can see here on the syntax. Now I will grant execute to my schema on DBMS Cloud so it's able to create external tables, and also grant read and read-write to the directories to this schema. Now I will download the external table file that I upload to object storage to my directory. And now I will connect with this schema that owns the external table. I can see the table already exists, but taking a look on the DDL of this table, it was created as a heap table, not as an external table. So I will rename this heap table, and I will create as external table now using DBMS Cloud create external table. And here I'm matching the original DDL with this call in DBMS package. So we can see that all the parameters, they have a proper place on this DBMS Cloud call. And after I do all the matching, I could create it, and we can see that the count star on the new external table match. And just for example here, I'm taking the first 10 rows so we get a sample of this data. So as you could see, differently from ADBD, on ADBS we had some minor issues that we had to manually fix. Now Mike, tell us if we can automate some of those steps with any tool.
We are done. Right? Thanks, Rodrigo. This was very good. And you would think, hey, okay, the guys migrated now. It's all good. I saw the differences between migration to ADBS and ADBD. All good. Database link, no database link. But sometimes databases are a bit more complex than the one we are using here. And so we thought, hey, let's start sort of a script automation. We have a different technique we would like to show you, and it uses still the basic principles of data pump and some scripts. So no magic ingredients here. We call this AMA. AMA is Autonomous Database Migration Automation. It's just a working title. So it's a simple solution, a script-based solution for migrations to ADB serverless. You can change it anytime. It has a single configuration file and it migrates in phases, and I would like to show you the different phases. You can also use it completely automated. So as soon as storage, FSS, or the object storage is in place, you defined everything nicely in the config file, you are ready to fly. Why are we doing that? Because migration to ADB is a little bit like making a movie. You won't start filming right away. Like take your camera and start filming. That is not what you should do when you do a serious movie. And also when we record these seminars, there's a lot of work around that. So we need a script book. Regardless if we do a virtual classroom seminar or if you direct a movie, we don't need to cast actors. That's the good part. We know the actors already, but in reality, you have to cast your actors. You need a film set, and you need so much more. So once you're done with that, then you actually start filming the scenes. And this isn't the whole story, because I can tell you by heart that the hardest part, and where the most work actually is spent to usually, or at least a significant amount of work, is the video editing and the cutting and putting things together and like doing all the magic at the end to produce an entire movie or a virtual classroom seminar. And this is like an ADB migration. So we thought, hey, we put this in a scripted way. So we start with a setup phase. In the setup phase, you examine your source database with CPAT, or we can utilize CPAT to do this right away. As we shown you in the last edition of this virtual classroom seminar series. Then you create a migration directory structure and you configure the parameters for the automation in a config file or parameter file. That's it. That's your prep part, and then we are ready to fly. So how do we do this? We need an input and an output directory. So you will find always in the script references to CPAT, because we plan to make this also a part of CPAT. So when you download CPAT, you can just kick that off and say, I want the migration scripts as well. This is the idea. Then we have a parameter file, CPAT migration parameters txt. We copy this into the input directory, and then we edit that with VI or your preferred editor. So in a parameter file, what do we need to adjust? And we show this, so I keep it very, very short here. Connect strings, of course, to source and target. That's important. Then you need an encryption password for data pump encryption, because we send the data pump file somewhere, typically over the internet, and therefore it needs to be encrypted. And we need to mount also the storage. So either FSS or object storage, as you've seen before, your choice. And you also need to tell the script if you want a tabular output or table output, I show you that, or if you want only the scripts for complete automation. So actually I ask for the tab output because I wanted to see and show people how the logic works, and this helps you also to optimize the logic if you want to optimize it by yourself. And of course, we have an official piece of documentation with that. So we wrote documentation. It's about 20 something pages, gives you the whole output, also the whole parameter file, the parameter options, everything is there. And of course, the entire flow from start till end to have your ADB migration run completely unattended, fully automated. Now I talk a lot, but it's time to show it. So Klaus, can you show how we can configure the parameter file, please?
Thank you for the introduction, Mike. Before we can generate migration scripts, we need to configure the AMA. What do we need? Well, we need a source database, in our case an ADB database, AMA demo, and I've already downloaded the database connection wallet. I need a source database. In my case, it's a PDB, and the PDB I'm going to migrate is PDB complex. Good. I need some local directories, AMA input. I need also a wallet directory, a dump directory, and an output. And I'm copying the wallet from the temp directory into the wallet directory, unzipping it, and adopting the sqlnet.aura file. Replacing the directory with the current one. Good. Setting TNS admin and adding for my convenience here a shortcut, TP urgent. Good. Testing the connection. Works. Perfect. Good. Now, we need to store somewhere the dump files. We can either use here a file system storage, or we can use an object storage. When we're using a file system, we need to mount it to the source database host, and then we don't need a copy. Or we can use here an object storage. So I'm going to use the object storage, and I need to know that I then have to copy my dump files using curl. So creating a bucket for now, AMA demo. And for my convenience, I'm creating a pre-authenticated bucket. So I don't need to work with my personal authentication bucket, permit read-write access, and also a name. It will expire soon. Okay. Pre-authentication request. Note down here this URL. We will need it later on. Close. Good. We are shipping by default a configuration file, a sample configuration file with AMA. In my case, it's stored in temp, so I'm copying it out to the input directory. Migration parameter sample to CPAT migration parameters.txt. Good. And we need to check out the connect string source. Going to reuse here the EZ connect string. I can also use TNS names or whatever I like. So localhost 1521. Okay, removing the other one and using TP urgent. And for the migration, to drive the migration, we are using the admin user. We will also get for the source database a script so that we can create in the source database the admin user with a password and the privileges it needs. We can exclude users from the migration, and we have to encrypt the data pump dump files with a password. That's my password I'm going to use. As we are copying the files from our local storage to the object storage, we are going to use curl, adopting the output directory now, where we are storing our dump files on our source server. Home, Oracle, AMA dump. We are changing here the URL to the one that we have copied earlier. The pre-authentication URL. We don't need to take care about the username and password, so just removing the rem. But it's a pre-authentication request, so it's not checked at all. Removing all file storage related parameters. And for the control file, we have two different kind of outputs. We have a tab and we have a script output. Mike will use the tab output format to explain more details. And I'm going to use here the script because I'm going to drive the migration later on. I'm going to use here the normal shell operating system, export data pump, import data pump with parameter files, so setting the API to false, and specifying here the output directory where at least our AMA is creating the output files. So, okay, almost done. We need to copy now our AMA script to this directory. Underscore create migration scripts and adopt the input directory. VI going down for now. And there's a CPAT input directory, and we are going to replace that now. /home. Oracle. AMA. That's it. So configuration is done, and I'm going to hand back to Mike.
Thanks, Klaus. And this doesn't look that complex, right? Let's go to the migration now. We start with a planning phase because we need to enable a few things or we need a few scripts. So here in this case, we need to enable potentially Java and OLAP on the ADB side, and we need scripts to create a migration user and queries our source database. So we have stuff on the source side, left side, and we have things to be run on the ADB target side. And we start with a script to enable OLAP in Java. And on the source side, we have scripts which gather statistics, queries the user, and create a migration user. Of course, querying the environment is not needed when you test this. But for a live migration, we highly recommend that because you don't want a connect coming in while you migrate and then changing data. This is not good. This is the tabular output I asked for. So you see on top of it, there's the planning phase with a little bit of explanation what we are doing there. And then again, we have the same schema I showed you on the slide before. We have the right side with ADB target and the left side with the source. And every script either tells you which phase it is. So on the very left of the slide, you see plan, either source or target. So the first script we see here is for the target, and all the scripts have sequential numbers. That doesn't mean that you can't run things in parallel. You can optimize that by yourself if you want to, but we give you a sequential ordering of the scripts to make it much easier to understand what is happening when. Our goal is really a simplified migration approach which actually works and doesn't give you surprises, but you are free to optimize that later on by yourself. Then we enter the prep phase. In the prep phase now, we generate the scripts for roles, profiles, schema definitions, function types, packages, and also for SQL profiles, SQL plans, or SQL patches. And then we run them in a zigzag order. The downtime actually would start here. So when you do it now for real, then downtime starts. And we start here with the source side, because on the source side, we create a script for the roles. We create the roles, then the profiles. With storage credentials, we export the schema definitions, import them, then functions, types, packages, come over to the other side, and at the end of the process, we alter the profiles, SQL profiles, SQL plan baseline, SQL patches, and so on. For the export import of the schema definitions, that is important to understand. That's the definitions, and we create them with open floodgates, because you saw in seminar 2, there's a CPAT checking if a user has objects but no quota on a table space. If you would create a user now with no quota, we can't create the objects later on. So this is why we create the users basically with open floodgates, and then at the end of the migration, we alter the users into the correct setting as it was before. This is how it looks like in the output file again, and you don't need these files. This is just a helper to get you a bit more understanding. When you run AMA in script mode, you don't even see that. Only when you use the tab option in the config file or in the parameter file, then you would see that. And let me show you how the order works like. So we create a migration directory, user stuff, we attach the file system, we export the roles, we import the role definitions. It's Then we export the profiles, we import them, and so on. So it's basically a zigzag going fac. And there are some phases one after another. This is how we work, and this ensures now that things are created in the correct order. And once this is done, we can really enter now the migration phase, the perform phase. And in the perform phase, we start with exporting the schemas and the audit trail, moving the files, and then the dump files, and then importing. So this is how it looks like. So we start with exporting the schemas, the audit trail, then copying the files over. Once the files are received, we can import the schemas and import the audit trail. So far, so good. Now we have the data, but there's much more to do. So the perform phase is actually not done yet. It goes on with cross-schema objects, privileges, profile adjustments, AQs, recompilation, and let me show how that works. So this is how the output would look like. So you see again, here's the audit trail, and it goes forward with SQL profiles and so on, goes forward. I just cut out a little bit here. I don't show you the full phases because there's no extra benefit of it. But in this perform phase, what happens script-wise is now we create the foreign key cross schemas, indexes, functional indexes, revoke transition privileges. We grant the right system, whatever object privileges, restore the final profiles. This is when the users get massaged. I call this the manicure and pedicure phase. Then we set the table-based quotas correctly. If there are network ACLs, we fetch them at this point and import them. And very important, we enable also the AQs and we recompile. And now we are done, almost. There's an optional phase coming. This is how the script sequence looks like. So you see most of the things now run on the ADB side. There's very little to be run on the source side. It's only the network ACLs. And the optional phase is then an object comparison, row export import comparison from the row counts, and also a check for the OLAP analytical workspaces. And since this is a lot of slide work again, I think, Klaus, it's your time to show how an actual migration works.
Mike shared the AMA workflow. Let's see the utility in action. We connect to the source database, check out the PDBs on this database side, and connect to the PDB complex database, the PDB we are going to migrate to ADB. We execute our create migration script SQL file, and it is creating the output in the defined output directory. So let's exit here, go to the output, and the control file always starts with an underscore, with 2 underscores. Remember, we configured to create a script output. So let's have a look at it. This file was created on a Linux operating system. So everything we see here looks like a shell script. Shell script. Does it work on Windows? Well, let's give it a try. We connect to a 11G database on Windows, execute the utility, go to the output, and check out the control file. Now the file extension is batch, and instead of the sh in front, we use the Windows typical call command. So yes, it also works on Windows. But let's switch back. In this control file, we have a plan phase, a preparation phase, and so on. And the plan phase only contains echoes in front because we can execute them up front before the migration downtime window starts. Let's have a look at one of those files. So enable OLAP Java, connects to the target database, and at least what it does is it enables a feature on the ADBS side. It enables OLAP feature, which automatically also enables Java, which requires a restart of the ADBS database. So that's the reason why we execute these scripts up front before the downtime window starts. What else do we have? We always recommend to recreate source statistics for dictionary objects and so on. You need to create the migration user on the source database sides. Depending on your workflow, this might take a while because you need approvals to change the source database. And shortly before the migration starts, we can set the job queue processes to 0 and enable restricted sessions. There are notes also mentioned in the shell script, how to do that, and so on. So please take a look at them. Now let's run it, the control file, in NoHub and in background and monitor it using a while loop. Okay, the loop tells us we have a problem here with the function custom password verify. Well, normally those kind of functions belong to the sysuser and the sysuser is not exported. So here you can create the custom password verify function manually upfront, or you can redefine the profile later on the target side. So let's wait until the refresh happens. And we will see, okay, for this particular object type, it was created, but with a compilation warning. The most important information here is it was created. So it exists on the target database, and we try to get it later on valid. Later on means after the migration. Here, these are the final steps. We have to compare objects. So our migration has finished. Let's exit here and check out the last steps in our control file. The last steps are the SQL recompile. That means we are recompiling our objects. What has happened during the recompilation? We see before the recompilation started, we have a couple of invalid packages for package body 6 and so on, a couple of invalid objects. And then the recompilation was done. And afterwards, after the migration, we end up with only one procedure and a single type. So that's something which is daily business for the DBA to check out if they are needed, valid on source, invalid on source, or whatever. But we also have a shell row count. Row count is a little bit misleading maybe. It is just doing an export and import log file verification of the amounts exported and imported. Let's have a look at this file. We can see it was progressing on all the export data pump files, on the import data pump log files. And wait, we have a missing data on our target site. Missing data is not good. That means we have a problem we need to check out. Let's connect to our source database, to the PDB. SH user, that might ring a bell sometimes. So let's first check out the SH user on the source database side. Is it an Oracle maintained user probably? No, not on source. But wait, let's switch to our target database, to the ADB. Yes, it's an Oracle maintained user on the target side. So that means I can't really do anything with the SH user. Let's see what happens with the object compare. The object compare shows I have 11 tables on source, but only 9 on target. Does it make sense to migrate that user? No, because it's a restricted user. Is there a way to detect that upfront and exclude the user from the migration? Yes, we have CPAT. Remember in one of our earlier sessions? We always recommend to check out the CPAT output, because then we could exclude this user upfront.
Thanks, Klaus. And now we've seen another technique to migrate your database into autonomous serverless. We are done. Just a few things at the end. So you can run AMA fully unattended, run a migration completely automated. So everything is possible. And as I explained before, you can even optimize phases. If you say, hey, I can run these things in parallel, if it makes logically sense, feel free, we'll optimize it as well. And the good thing is, if your source is on MS Windows, AMA can do this as well. So you can migrate a database from Microsoft Windows into Oracle Autonomous Database with these scripts. That's cool. I like it. What we are working on right now is we have already written extensive script for database links, but it requires a two-phase approach to really catch them, and it's not perfect. So we are not including this right now. We also have something in the making for directories, for external tables, and we are also looking into XML binary as long as Autonomous doesn't support that. And of course, we have also some for Apex applications. So it's coming. Please stay with us. There's work in progress. And if you have a good idea, or if you make an extension to the scripts, which you say, hey, let me share this with the Oracle guys, please give it to us. Then everybody can benefit from it. And this brings me to the next topic. Now you've seen data pump migrations with or without network link AMA, but there are more sophisticated tools. And we have the first guest speaker here today. So let me invite Ricardo Gonzalez to explain you in the next minutes about ZDM, or as they keep saying in the US, CDM, Zero Downtime Migration. Ricardo, we are happy to have you here today.
Hello, my name is Ricardo Gonzalez. I am the product manager for Oracle Zero Downtime Migration, ZDM, and I wanted to share with you how ZDM powers migrations to the Oracle Autonomous Database and overall Oracle Cloud. ZDM is the main engine for database migration at Oracle. It is a downloadable binary. You set it up in a virtual machine, and you just need to provide connectivity from ZDM to the source database, target database, and any additional required components like storage, Golden Gate, etc. ZDM basically wraps up and orchestrates all the best practices for Oracle Maximum Availability Architecture, unless you customize your migration, being physical, logical, or hybrid migration, depending on the use case and what you're trying to achieve. And really important, ZDM is free of charge, as well as its associated technologies. In this specific video, I'll show you how a migration to the Autonomous Database works. We will see a demo on how a live migration will look like. On the left, you'll see the ZDM engine, and on the right, you'll see a graphical representation of the migration step by step. You can see here, we're representing graphically your data center, your application connected to your source Oracle database, ZDM on a virtual machine. And then, of course, on the right of the graphic, we can see Oracle Cloud, the actual cloud deployment, and the autonomous database that is going to be the target. You'll also notice there's a Golden Gate hub. This, when you're migrating to the autonomous database, it's configured by yourself, but it's provided by us. There is a marketplace image in the Oracle Cloud Marketplace called Golden Gate for Database Migrations that offers Golden Gate specifically for ZDM. So basically, you accept the terms of licensing, and then a Terraform script creates and deploys a compute node where Golden Gate Hub resides. Configuring ZDM implies also providing several parameters at a response file level in which you will specify data pump settings, Golden Gate settings, of course, for Golden Gate, the URL and other authentication values for the actual Golden Gate Hub, because ZDM will take care of orchestrating everything and including configuring the Golden Gate Hub, microservices, extract, replicate, etc. And then, of course, syncing up source and target databases. So ZDM actually does everything for you, right? So just out of the bat, what we're seeing here is like the whole architecture, but I'll go step by step and show how it works. And on the left, you're seeing the actual terminal where ZDM runs. ZDM is a command line based tool, and then we issue one migration command. But we're noticing like we ask for the migration command to say pause after. And this is because we're telling ZDM, when you reach a certain stage, we want you to pause. Everything will stay active, meaning the source, the application will keep a source workload at the source database level. And of course, Golden Gate will keep replicating between source and target, right? Basically, depending on where we ask ZDM to pause, that's where we'll like say, right? In this case, we're asking ZDM to please pause after having done reached the phase of the Golden Gate lag monitoring. So basically, I've done everything, and I'll explain and go step by step. But ZDM will take care of that for you. After issuing the migration command, ZDM will prompt you and ask you for different authentication parameters, as you can see here. Then ZDM will work in the background because we can do multiple migration jobs in parallel, actually. So you can run multiple migrations for different databases at the same time. Once ZDM is running the migration job, you can just query the job, as you can see we're doing here, and then see each one of the different stages where the ZDM is executing. So at first, ZDM is actually, connecting to the source, target, validating that everything is in place, everything is fine, everything checks out, basically. We can even run a PreMigration Advisor called CPAT, and then if you run an evaluation mode, ZDM will tell you, okay, there's certain things that you need to adjust, data pump or golden gate wise, etc. Now, the next step for ZDM is to connect to the golden gate hub and configure a microservice. It has to configure two, but initially it configures one, which is the extract. That extract will actually connect to the source database and start capturing transactions, right? And then start generating trail files that then will be used by a second microservice that we will configure ZDM at a later moment, which is a replicate. And that replicate will feed out of the trail files, start applying transactions at the target database. All of this coordinated by ZDM, right? Which is actually quite neat because you don't have to have any golden gate knowledge. Now, ZDM actually queries the source database and tries to understand what data is supported by Golden Gate, so that only asks, of course, Golden Gate to replicate what is possible because it cannot overcome any limitations by the technology that ZDM uses, right? Now, after configuring the Golden Gate extract and starting capturing transactions, ZDM then will start a data pump export job and transfer it to a backup location. So if you're going to autonomous database, it could be the object storage or FSS, right? Because then this will be used later for an import and creating the actual target database. Really important though, right? Like you can configure ZDM to do that data pump job at a schema level, object level, full export, etc. You name it. And there's a feature of ZDM. We are not showcasing it today, but basically it's called reload, in which ZDM will only export the objects that are supported by Golden Gate, will only replicate, of course, because there's no other way, the objects that are supported by Golden Gate. Then after the switch over, like ZDM will go back to the source and do an offline export of all the unsupported objects. And that's what we call reload, because then we do a second import to ensure that everything is fine. But going back to our migration, after having set up, the Golden Gate extract, and then of course initiating the data pump export, we move on with the migration and of course start the import process to create a new database at the target level. After that, after having done the import, we are now doing, of course, or going back to the Golden Gate Hub, and ZDM will configure, as I mentioned before, a second microservice, which is a replicate, and start applying the changes and transactions to the target database, the target autonomous database. Now, is in this moment in which ZDM goes and realizes, okay, now I'm actually applying transactions, right? I'm still capturing active transactions from the source and then applying transactions at the target level. But I was asked, because as you remember, we do a pause after. So at this moment, we're just querying the lag with Golden Gate, but I'm going to pause. So ZDM pauses. It doesn't mean that everything stops, right? It's just ZDM that is idle and waiting for you to check if everything is fine. So because ZDM is paused, Golden Gate is still active. The application is still executing and having an active workload on the source database. But then we can do some testing, which is exactly what we're going to do right now. So let's step out for a second from the ZDM command line. And let's check the terminals where we can connect to the source database and the target autonomous database. On the left side, you'll see the source database, and on the right side, you'll see the autonomous database. Basically, what we're doing here is checking out the contents of both databases and just verify that the actual application is still ongoing, even though the migration job with ZDM is paused. So at first, we're going to do a simple query and check that the employee table has the same records at both source and target. Then after that, we're going to do a select of records that do not exist, right? Once we do that, we can then go ahead and do an insert of those records at the employee table level to the source database, right? And we can check that it's there. And then we go to the target database and actually do the same, right? Not the actually insert, but the actual query. And we can prove then that because, of course, Golden Gate is still working because ZDM is paused, but the replication is ongoing, right? Then we can then, if anything that we're doing at the source level, the transactions will still be replicated and the changes will be replicated, captured, of course, and then applied at the target level in the autonomous database. Right, and this can keep on ongoing indefinitely, so you can do all your testing, etc. Then, of course, we're gonna go back to the ZDM terminal to just continue the job. And basically, when that happens is ZDM will say ZDM CLI resume job, the actual job ID of the migration job we started, and ZDM will then query that there's no more lag, and then take care of the actual switchover. We have a lot of best practices on how to handle application switchover for logical migration, and ZDM of course automates this for you. And then once it's done, it will do several post checks for the migration and ensure that everything is fine. So as you can see, from A to Z, ZDM will help you migrating your databases from on-premises to the autonomous database, setting up everything you need, helping you with data pump exports, helping you with even with encryption, helping you with Golden Gate setup, etc. It's a fantastic solution, and I really hope this was helpful for you. Thank you.
Thank you, Ricardo. Interesting demo. Now, another way to migrate is by using the OCI Database Migration Service. And who better to tell you about that than the product manager for the product? Take it away, Jorge.
Hello, my name is Jorge Martinez, and I work as a product manager for OCI Database Migration Service. And we all know that migrating databases into the cloud remains as one of the most complex steps into the cloud adoption. This is not because the lack of tools, but because preparing, integrating, and executing the migration is still a challenge. OCI Database Migration Service, or DMS, has not invented a new way to do migration, but it was created to simplify and automate the existing process while still giving the user full control and visibility. DMS is a fully managed and cloud-native service that orchestrates homogeneous logical migrations of Oracle and MySQL databases from on-prem AWS RDS, other cloud service providers, and even OCI cloud regions into OCI. It uses Oracle-proven tools like CDM to orchestrate data pump for offline scenarios, and Cloud PreMigration Advisor, or CPAT, to identify incompatibilities. Whenever real-time online replication is a must, Golden Gate is used, but the service hides the operational complexity behind a guided workflow, so the user doesn't need to worry about it. Here are some of the most common use cases our customers address with DMS, like migrate to modernize from versions like 11.204, 12c into autonomous database or other OCI commanders databases, consolidating multiple databases into one Exadata database service, or migrating outside of AWS RDS into OCI with minimal effort. And they also use it to perform zero downtime migrations using Golden Gate for change data capture. The following is a simple demo migration of a base database into autonomous database. Okay, for the navigation, please go to Migration and Disaster Recovery, and then go to Database Migration and click on Database Connections. Now we click on Create a Connection, and here we are going to create a container database connection followed by a pluggable database. So we select the type as Oracle database and provide the vault and the key where we are going to store the credentials. Following to that, we select our database, and we need to provide the credentials for the initial load user and also for the replication user. In this case, we are going to provide different credentials for the replication. Once that is completed, then we proceed to create the connection. All right, so once we have the connection, we can still do a test and verify that it is working fine. In this case, it is working, so everything is fine. Let's continue with the pluggable database connection. It's very similar. We just need to provide specific details. Again, we provide a name and select the same connection type. We also finish, select the database and specify the pluggable database this time. And we still need to do the same with the initial load, provide specific user and password as well as for the replication user. Okay, so now we have the container database and the pluggable database connections, and we need to proceed to create the target database connection, in this case for the autonomous. And we are going to start selecting the connection type as autonomous, and then just provide again the vault and the ID. And we select the database. We provide the initial load, user and password, and also the replication. We click on create. Okay, let's do a quick test connection. Now everything seems to be fine, and we can go and create the migration. During the migration, we are going to select these 3 connections. So we're going to start giving a name, then selecting the source database connection, which is our PDB. Now the target database, and we select the transfer medium, in this case, object store. Here I am passing all of the data pump settings, which is the one of the directories, the path, and also where is my wallet stored. I'm specifying here that I want an online replication. And here in the advanced options, I can select what I want to include or exclude. For this test, it's going to be one table. But of course, you can specify whatever you need to migrate. Okay, so, once our migration is in status active, then we can move ahead and validate. The validation is going to review that everything is fine with regards to the source and target connection and also the data pump settings. We can also open the PreMigration Advisor and revise if there is any incompatibility. If there are, we can see an issue, impact, and an action. So we can also take the corresponding resolution. We don't have anything here. This is just a small migration. And now we can jump into the real migration where the data is going to be moved. And we have the option here to select where do we want the migration to stop. It's going to stop by default when the source and the target are in sync and the change data capture is below the threshold. During the monitor replication lag, service will keep replicating any change, and it's going to be waiting for the user to perform the switchover. Once the switchover is completed, the workload can start on the target. So in this step, it has completed, and now we just need to run the cleanup, which is the final phase. This is the end of the migration, where our migration is going to be marked as successful. Technically, DMS stands out because it automates every critical process and presents a friendly graphical interface to the user. So you don't need to run or create any manual custom scripts. You don't need to install any software or manually run any CLI commands. This is going to prevent human errors. The service has control over the process and allows you to test your connections, run evaluation and migration jobs, and also review errors and analyze the recommended remediations. And also, it's a centralized monitoring place. The best of all is that you don't need to pay any additional cost because the service is free for 6 months per migration.
Thank you, Jorge. This was really good now. We heard CDM, DMS, and there's also migrations to hybrid environments. And I'm happy to introduce now our third speaker. And Daniel will interview Sinan. Daniel, please.
Hi, Sinan. We are seeing a lot of interest in autonomous database at Azure. I know you're an expert on the topic, but before we start, could you please share a few words about yourself?
Sure, Daniel. Thank you for having me. I'm Sinan Petrostoma. I'm part of the database high availability product management team and focus on multi-cloud. I help customers use Oracle Database at Azure, Oracle Database at Google Cloud, and also Oracle Database at AWS.
Good to have you here. If a customer is thinking about going to Autonomous Database at Azure, is there anything they need to be aware of?
Yeah, Autonomous Database at Azure is the same Oracle Database Service on OCI. Same features, same pricing, really the same. So the difference is that the hardware, the Oracle hardware, is placed in the Azure data center. That's how we can achieve such low latency between the database and the Azure applications. So you can access the Autonomous Database through your Azure network or via the OCI network, actually.
Okay, well then how do you migrate your data from on-premises to Autonomous Database at Azure?
Yeah, good question. If you have connectivity between your on-premises data center and OCI, you can use the same tools and follow the same steps as migrating to Autonomous in OCI. It is completely the same service. You can use Zero Downtime Migration, ZDM, Database Migration Service, or do it manually using Data Pump and Golden Gate. In this case, as a storage location, you will use OCI Object Storage as usual. However, existing Azure customers usually have connectivity to Azure only. Then you need an alternative storage for the data pump dump files, as we can't use OCI object storage in this case. So you can use an NFS file share instead, for example. We have already validated ZDM using Azure files, and it is fully documented.
Okay, can you share some further details on using Azure files instead of the OCI object storage?
Sure. Autonomous Database can access Azure files or any other file share. And to mount the NFS share, you must use the DBMS Cloud package in Autonomous Database, which for security reasons doesn't allow you to use an API address to connect to the remote NFS server. Instead, you must use the fully qualified domain name of the NFS server. So, since the autonomous instance is in an Oracle maintained network, we must add an A record in the DNS private zone in OCI. So the autonomous instance can resolve that FQDN to the IP of the NFS share. But the documentation has all the details. It is really a minor task.
Okay, and then what about migrations where minimal downtime is needed? How does that work when you migrate to Autonomous Database at Azure?
Yeah, the same applies here actually. If you have OCI connectivity, you can use the Database Migration Service. Also, we have validated the ZDM logical online migration workflow that works for both the OCI and the Azure network.
Okay, well, it sounds just as easy as migrating to Autonomous Database in OCI.
Yes, indeed, it is. It is really well documented. So as long as you follow all the steps and don't take any shortcuts, you shouldn't hit any road bumps.
Well, that's good to hear. Thank you, Sinan.
My pleasure, Daniel.
So, all is good, right? We've moved the data. CDM, DMS, AMA, none of those tools reported a problem. So, is everything fine? Some of the customers that I work with, they have specific requirements that they must be able to prove that the migration was successful. It could be their management. It could also be auditors or regulators requiring that they can prove nothing changed in the migration. A logical migration is different than a physical migration. In a physical migration, it's very easy to validate the migration because we simply move the entire database from A to B. But in a logical migration, we're kind of taking things out and moving them into a different database. A lot of things can happen here which we don't face in a physical migration. In ADB, for instance, we do a lot of transformation underneath the hood. We store things differently. And how can we actually validate that our data, as seen from the users, are exactly the same after the migration? The first step is to validate the data pump operation so that the export and the import happen without any problems. If you are lucky, You'll face a situation like this where data pump says, well, all is fine. I didn't face a single issue in my job. This sometimes happens during an export, but on the import side, there are often things that are noted by data pump which you need to attend to. So perhaps this is a more realistic case. In this scenario, we have 56 errors. That is not that bad. I have seen migrations where we face thousands, or even one case, we had 103,000 errors. How can we deal with those? Well, this is not data pump's fault. If we face a situation during imports, we, data pump, is not often able to determine whether or not this is a problem. Take, for instance, this situation. The user already exists. Okay, well, we can just keep on importing the data. Everything is fine, right? But what about the privileges and the roles? Is the user created in the same way? And why did that user exist already? Were we importing into the wrong database? Or was the database tainted from a previous one? What was actually the issue? So it might be fine. There could also be an issue here. This one, view and compilation errors. We see that often. Depending on the order of views, if we import one view depending on another, we might see a compilation warning. But after the import, when you recompile all the objects, if everything is fine, if there's no compilation errors, well, this is something that you can safely disregard. This, for instance, this is a resumable wait. We had no more space in our table space, but someone cleared the issue behind the scenes and we could continue. So this is a perfect example of something that is completely ignorable. This one, on the other hand, value too large for column, well, something went wrong in our target database. We no longer have room in our columns to hold that data. And this would be an example of something that you need to attend to, definitely. So data pump can't really tell which issue is fine or not. You need to come in with your knowledge and determine that. This is an import log file that I got from one of the customers I worked with. The import log file was 29 megabytes, consisting of almost 200,000 lines in the log file. How can any human being interpret that much information? That is completely impossible. Luckily, there's a tool that you can use, the Data Pump Log Analyzer, which can help you assist and determine the causes of these errors in your log file. When you run the tool, it can tell you how many Aura errors were in there, and you can get a summary of the overall operation. And then you can dig into the detail. You can use the -E command line option, and it'll then summarize all the Aura errors and tell you how many it found in the log files. In this case, for instance, we have some issues with comments in our database. Well, that could be a problem. Why do we have data loss? But comments are something that we can easily add afterwards, so potentially not that big a deal. And again, we have PL SQL objects here that have compilation errors. If they recompile afterwards, then all is fine. But we can use the tool to get a really good overview. There's also an HTML report that you can use, which in some cases are easier to navigate. Now, this is not an Oracle tool. This is not an official Oracle tool, but it is created by an Oracle employee, Markus Döringer, who is really one of our migration superstars. He does migrations more or less every day, and he saw the need for such a tool. So he built it, and he's such a kind guy that he made it available for everyone to use. It's free to use. You can find it on GitHub, and you can help improve the product if you even want to. So this is a really helpful tool to assist you analyze the data pump log files. And it's not only good for investigating errors, also if you have performance issues or if you want to see where is data pump spending all that time, you can use the tool to assist in those kinds of investigations as well. Now that we've checked the data pump log files, let's move on and check our database. You can check your database on 3 different levels. You can start by looking at the objects. Do we have the same tables and indexes and views in our target database? Do we have the same amount of rows? And how about those rows? Are they actually the same as well? If we look at the objects, you should first do a recompilation so we can sort out those issues about depending objects, and then we can compare the number of objects in our source database and our target. This is one way of doing it, We have a database link from the ADB instance back to our source database, and we can do a query in the data dictionary on DBA objects, and we can ensure that we are not missing any objects in our target database. If you don't have network connectivity, you would need to output the information to a file and then do another kind of comparison. So it sounds trivial, but depending on how you use the database, there are some gotchas. One of those is around advanced queuing. Now in your source database, if you're using advanced queuing, well, you have a queue table. This is one that you have created initially. And then underneath the hood, the AQ infrastructure will create a lot of supporting objects. But look, in our target database, after importing the queue table, we don't see the same amount of supporting objects. And this is by design. The queue infrastructure will create those objects as they are needed. So if you need a dead letter queue, well, we'll just create it when we need it, not up front. This is, of course, something that you need to take into consideration when you do these kind of comparisons, is that for some object types, you will see less objects in the target database. This is perfectly fine. There's no issue here. And you might be able to see that in other situations, database links and directories are examples where things will probably change as you move them to the ADB instance. Now moving on and talking about rows. We can compare the number of rows that we exported and imported, and we can also do a count on the database to be sure that we have the same amount of rows. The good thing is that Datapump keeps track of the amount of rows that are unloaded and loaded, and we can use that to our advantage. If you're familiar with Datapump, you have seen a log file before, and you know that the tool writes the number of rows that are exported and imported. So you can now apply a little bit of grep and org magic, and you can transform a Datapump log file into a file which consists of the table or partition name and the amount of rows that we have. You generate a file for the export log file and for the import log file, and then you can use your favorite diff tool so you can easily see on which object do you have a different row count. But what if you do a logical online migration? We can still check the initial load with the Datapump log files, but what about the replication with Golden Gate? How do we ensure in the migration window that we have the same amount of rows? Now this is where you need to use a query. You can do a select count on the table and then compare the number. Of course, we want this to happen as fast as possible, so we can use parallel query as well. You can store all that information in a file and compare the files like we saw in the previous example. But the issue here is that when you do a select count on the table, the database will need to do a full table scan. Or if you are lucky, if you have the right index, we can also do an index scan, which will be a little faster than a full table scan. But I think that this goes without saying, the bigger the database, the bigger the tables, of course, the longer it takes to actually do that count. After looking at rows, we can start looking at the actual data. The idea here is to ensure that data as it looks in the source database is exactly the same in the target. The optimal approach here is to use Oracle Golden Gate Veridata. This is a perfect companion for Oracle Golden Gate. And this would be the best and fastest way to ensure that all data in our target database is exactly as it was in the source database. But it is separately licensed. It is an additional product that you need to configure and use. If you want to use something that is inside the database, you can use the DBMS comparison package, which requires a database link from the ADB instance back to your source database. Then it can do some smart comparisons and find rows that are differing in the source and in the target database. It is not as fast as Veridata, but it can still do a pretty good job comparing those two databases. And for comparing individual rows, you can use the DBMS crypto and the standard hash function to calculate a checksum for a row and then compare that as well. But to compare an entire database, you need to use one of the former two options, DBMS comparison or Veridata, whereas for specifics, you can use the hash functions. But comparing a big database to another big database, that takes a lot of time. Do you have all that extra time in your maintenance window to do a full verification? Probably not. So what can we do instead? Up to the migration, you'll be doing a number of test migrations. As you work on your test, you'll be creating and refining your runbook. In the end, when you have everything right, you do a final test. On the final test, you can do a full verification. We are before the migration, so we have enough time. It doesn't matter if that full verification takes 1, 2, or 3 days, we have enough time. You use the runbook that you have refined in the previous tests, and from this time on, there will be no further changes to the runbook. This is exactly what you will do in the actual migration as well. But we will run the full verification on the final test. So a few days later, or the next weekend, when we do the actual migration, we can just do a partial verification. Since we are using the runbook from the final test, we know that if we do it exactly this way, things will be fine. We just verified that in our final test. So now in the migration, when we are short on time, we can settle with doing a partial verification. What do I mean with a partial verification? In contrast to a full verification, where we have enough time, in a partial verification, you are constrained. Perhaps you are only allowed to use 30 minutes for the verification. So together with the business people, you need to look at your database and identify those tables that has the most importance to your business. It could also be tables that are covered by some sort of legislation. And then you build a plan. You identify the tables and decide what you will do with them. If you have a table with business data, you might decide, for instance, to do a random sample of 10% of the data. There could be other tables where you decide to do no verification at all. This could be generated data, for instance, some sort of calculations, or it could also be tables where you only do inserts. If you later on find out that something went wrong in the migration, you can always re-import those data. On the other hand, you could have regulated data, for instance, financial transactions, and on those tables you decide to do a full verification. And there could be other data which is only hot in the beginning, for instance, an order system. As soon as you insert the order, there will be some updates as we process the order. But once that record becomes a few months old, it is rarely updated. So in that case, we might decide to verify or validate only the last 3 months of data inside our maintenance window. The overall goal is to find a balance between the time that you can spend in your migration window and the amount of data that you actually want to validate. You need to find somewhere in the middle where those two can meet. Now, to make the validation or the verification process run as efficient and fast as possible, I strongly recommend that you automate it. This also allows you to reuse the validation in your previous tests, and be sure to store all the information, output and log files. Keep it safe for investigation later on. Now, for the final words, I'll hand you over to Mike.
Whoa, that was a lot. But we migrated successfully. So you need to try it out now and share your experiences with us. We are still looking for reference customers. So if you have a cool project, if you're going to migrate to ADB serverless or dedicated, get in touch with us. Remember, we showed you our email addresses. You can always contact us, ask for advice, share your experiences with us. We are really keen to learn about if what we told you is really also completely working in the real world, or if you have other experience or additional things we need to talk about, learn from you, and also share with others as well. So our email addresses are here. Our blogs are here. We are happy to share with you. Share with us as well, please. And don't forget to sign up to our YouTube channel. Subscribe to our YouTube channel. No marketing blah blah. No buzzwords. Just pure tech. Every 2 or 3 days, a new short video. You can watch it in the train or when you're on a plane or whenever. So please subscribe to our YouTube channel. And then it's time to say thank you. So thanks for staying with us today. We showed you the migration in different techniques with different tools, different ways into ADB. And next time, in a final virtual classroom seminar in a few weeks, we would like to show you how ADB can change a DBA's life to the better, of course. And there you should tune in again. So we are looking forward to see you then. Thank you and goodbye.
I'm a migration superhero on a wild ride, upgrading databases. I won't be denied with Oracle's auto upgrade. I'm on my way, moving to Oracle 23 AI. No time to delay. Taking care of my standby, keeping it on track. Rotating and rocketing, no turning back. Oracle DBS, we run this world tight. From the server room to the darkest night. Migration superhero, I'm taking the lead. Upgrading databases at lightning speed. Oracle's in my veins, running through my soul. Bringing the power, rocking from control. Control.